This conference will now be recorded.
Hey guys, can you hear me?
Yes, Suresh.
Yes, we can hear you.
Okay, just a couple of minutes, guys. We'll get started. So, how many of you have been part of the demo, guys? Either last week's demo or the previous week's demo. So, I have taken two demos, right? One on 19th and one on 26th or 27th. So, ho-
Yeah, I was on the 19th one, Suresh.
yeah, hi Ravi.
Hi, Suresh.
Cool. So only three were part of my demo, and this is a new session for rest of the folks. Okay. Cool. So people who were part of my earlier demos, so you have to bear with me. I'm gonna uh, repeat the same thing more or less. Okay, as today is the first session. Okay, and first 1 week we will go little slow, guys. I mean, probably till Monday or Tuesday. Okay, and then we will pick up the pace. Okay, so because most of the folks are completely new to programming, they might not be having enough, or they might not be having enough exposure to programming. So to bring them up to the speed, first 1 week sessions is definitely going to be slow. Okay, so you can expect around 40 to 45 minute sessions in the first 1 week. Okay, and then we will pick it up, and then you'll see the full-fledged 1 hour sessions starting from next week. Okay, so let me introduce myself. I'm Suresh. I having 9+ years of experience into data engineering. Have worked on multiple clouds. Our major expertise is into Azure, guys. So basically, I'm an SME for Azure Cloud when it comes to data services or data engineering. Okay, I have also worked on GCP and AWS too, but not as extensively as Azure. And I have been using Python from almost maybe 5.5 years now. Started in late 2017. Before Python, I was using Java and Spark, Java and Scala. So basically, be it any programming language, I have never used it for web application development or application side of the things. but I have been using Python for developing data engineering applications, data science applications, and then in the data analysis space. Okay, but not predominantly on web applications. Okay, so I do have some hands-on with them for implementing REST APIs and all, but not as much as a web application developer. And talking about trainings, I have been taking Python trainings from past 3.5 years. The moment I have got couple of years of experience into Python, and I started taking, Python classes. Prior to that, I was taking trainings on data engineering. So I started with Hadoop, then Spark, and currently I'm taking data engineering course, Azure data engineering course. Okay, so yeah, this is a brief introduction about me. Now, if I would let you guys introduce yourself. So probably you can use chat window to introduce yourself in this format. Probably your name, sorry, your name, your experience, and then your skill set. Okay. So for example, in my case, one moment, guys. Guys, just give me a second. So in my case, Suresh, experience is 9, and then skill set is data engineering. Okay. So would like to hear from you. So Kishore, 11 years SRE, Ravi, VMware, Cisco UCS application programming monitoring. Okay. Pranita, 10 years. MQ, when you're saying MQ, is it a Q, Rabbit MQ, or something else, Pranita? Kaushik, 3 years software tester. And if somebody is a fresher, you can just mention your name and fresher, something like this. Okay, good. So nice to meet you all. There are people with various experiences and then from various fields. Again, that's the beauty of this training course, guys. There will be a lot of learning from different people. It's not just a one-way talking. We will try to make it as interactive as possible, sharing our experiences, right? So, yep, I hope you must have gone through the course structure, what we are going to teach in the next, couple of months. And you must have got all the details from the career IT folks. Okay, so let's get into the Python programming, guys. Okay, there are few things which we need to revisit whatever we have discussed in demo, because most of the folks who are joining today are not part of the demo. Okay, so we'll start with a programming language, what exactly a programming language is. So even before that, let's try to understand what a program is. Any idea what exactly a program is? And one more thing, guys, in my sessions, you are free to use Google because I ask questions for interaction, but not to test your knowledge. Okay. And secondly, I prefer you guys to attend sessions from laptop rather than mobile. I mean, if it is possible. Okay. So you will have a bigger screen to see, and you can be as interactive as possible. Whenever you need to Google something, you can just do it and then, you know, uh, interact with me. So I have got one answer, set of instructions. And whenever you are pinging, if you are shy to ping it to everyone, you can ping it to me personally too. Whenever you ping it to me personally, I'll not call out your name. Okay. So I have got one answer, set of instructions. Yes, set of instructions. Okay, program is nothing but a set of instructions given to your computer. Now, let me ask you, why do we need to give set of instructions to your computer? So your computer can't do things by itself, okay? Or maybe what exactly are these set of instructions? Okay, we'll try to understand, guys. Your computer is a compute machine. Your computer is nothing but a compute machine. So what do I mean by this compute machine? How does it really help me? So basically, it's not self-intelligent. It will not be able to do anything by itself. It will not be able to compose a mail by itself. It will not be able to play a movie by itself. It will not be able to, run a browser by itself. Okay. So will you be able to do it? Yes, you will be able to do it by passing some instructions to your computer. Say, for example, you want to play a movie. Okay, so you will play a movie using a media player. That media player is nothing but the set of instructions you are giving to the computer to get your task done. Here, the task is playing a movie, and you are playing that movie by using a media player. Media player is nothing but the set of instructions given to your computer. As simple as that. Okay, you might ask me, boss, I'm not writing any code to play a movie, or how come VLC Media Player is my set of instructions? Definitely yes. At the end of the day, in the back end, some code is getting executed, guys, which might not be visible to you because you are abstracted by a beautiful UI provided by VLC Media Player. Okay, so whatever operations you do using a VLC media player like a play button, pause button, okay, or maybe you want to forward some scene, or maybe you want to drag the scroll bar, or maybe you want to change the resolution, or maybe you want to zoom in, zoom out. The moment you click any of these buttons, some code is getting executed in the backend. Okay, that code is nothing but the set of instructions. Okay, so for example, when you click on the pause button, your computer doesn't know how to pause a movie. So basically, you are writing some set of instructions on how to pause a movie. Okay, and the moment you click on that pause button, those set of instructions will be executed. So for example, right now I'm using GoToMeeting. We are using GoToMeeting to attend these interviews. Maybe I want to share my screen. Again, some set of instructions is running in the backend, which would allow me to share my screen. Maybe I want to mute or maybe I want to unmute. The moment I click on those buttons, some code is running in the backend. Okay. So these are nothing but the set of instructions given to a computer, right? Guys, just give me a minute. I'll have to collect a package. I'll be right back in 1 minute. Hey guys, I'm back. Sorry about that. Okay. So are we good with the definition of a program?
Yes.
Okay. So now let's try to understand what exactly a programming language is. Any idea what exactly a programming language is? Any idea? Come on, guys, Google it. Programming language is a computer language used by programmers to communicate with computer. Yes. Machine understandable language to some extent, correct? Okay. Yeah. Now, talking about a programming language, we have talked about a program, tried to understand what a program is, which is nothing but a set of instructions. And you need to pass this set of instructions to a computer, right? Which for which you need a means or a medium. So that is what a programming language is. That is what a programming language is. A program is nothing but a set of instructions. Okay, and the programming language will provide a means for you to interact with your computer or to pass this set of instructions. Okay, so there are different types of programming languages we have, guys. We have to start with basic C, and then we have C++, and then we have Java, we have Python, we have Scala, okay, we have Golang, we have R, okay, and then now we have something called as Lua. Lua is used in internally in Google. I have never used Lua except for developing user-defined functions in Google. So I was working for Google as a contractor from Deloitte. Okay, so that is when I have used this scripting language Lua. Okay, and then there are a lot of other programming languages to list, but these are the top programming languages. I forgot C sharp. Okay, so these are the different programming languages we have, guys. And the programming language what we gonna learn is Python for various reasons, you know. Okay, so why we have to learn Python? We spoke about that during the demo. We'll talk about that. Might not be right now, but there is a separate topic called Python features. When we talk about Python features, I'll get back to uh, why Python. Okay. Now, the guy who invented Python is any idea? Guido von Rossum. Okay. So he's the guy who invented Python, guys. Okay. So far, so good. Okay. Now, I have explained, program is nothing but a set of instructions, and we have discussed what exactly are the set of instructions and how we pass on this set of instructions, which is by using a programming language. Okay. Now, my next question would be where these set of instructions are getting executed. Where this set of instructions are getting executed. Any idea? Compiler? Variable? Okay. We'll talk about all these components, guys. I'm gonna connect all these dots. Okay. Any other answers? Okay, so these set of instructions will be executed in your processor. Okay, in processor you have cores. Okay, so say for example you have a quad core processor or an octa core processor or hexa core processor, right? So what is the meaning? Octa core processor you have 8 cores. Okay, quad core processor you have 4 cores, and then hexa core processor you have 6 cores, right? So currently I'm using Ryzen 7, which is octa-core processor, which means I can run 8 processes in parallel. So for example, if you are using i7, i7 is again an octa-core processor. Okay, so what exactly is this core? Any idea? CPU, okay. Again, let me ask a couple more questions. How many of you have heard about space complexity and time complexity terms? And even before I talk about space complexity and time complexity, how many of you are from computer science background, guys? Computer science or information technology, IT? I see one, two hand raises. Chaitanya, Hemant. Who else? Three, Kiran. Four, Akanksha. Good. A lot of you. So how many of you are intimidated by these terms, space complexity and time complexity, while learning data structures? I would assume a lot of you. Okay, so I would say even today, a lot of people are intimidated by these two, space complexity and time complexity, because you attend interviews from product-based companies like Google, Amazon, or JP Morgan Chase, Morgan Stanley, not Morgan Stanley, Goldman Sachs, my bad. Okay, and maybe Walmart. They all need data structures knowledge, guys. PayPal. Okay, so you will get a lot of questions on data structures. And the moment you get questions on data structures, they call it as DSA, data structures and algorithms. They will talk about space complexity and time complexity. Okay, so now let me try to give you a brief understanding on what happens with your program um, when you start executing it. I think I might have to request for GoToMeeting, sorry, Zoom meeting. I'm not really comfortable with this UI. It is not providing inbuilt pen. Let me open my whiteboard. Okay, so generally whenever you want to talk about you know any compute, right? When it comes to your computer, there are three components that will come into picture, guys. One is RAM. Okay, assume that this is a RAM. Okay, and the next one is processor. Okay, so at domestic level or for home usage, we talk about i5, i7, i3, but that will not be the case when you get into the bigger scale, guys. Okay, so we talk about only core. So how many cores does your processor have? 16 core processor, 32 core processor, 64 core processor. or maybe 50 core processor. That's how we talk about. Okay, they're all huge workstations. So for now, I'm gonna talk about a quad core processor. It doesn't really matter for me whether it is an i5 or a Ryzen 5 or a Ryzen 7 or i7. Okay, or maybe Intel processor or an AMD processor. It doesn't really matter for me. Okay, and the third component is storage. Okay, so you will have to understand this terminology, guys. So RAM is what we call as memory. Hard disk is nothing but storage. There is a reason why we call them as memory and storage. So because this is the permanent storage, okay, or you are persisting something on disk. And here everything is volatile. This is just memory. Whenever you store something in RAM, we call it as, I mean, memory is often referred to as RAM, guys. Sorry, RAM is often referred to as memory. Okay, and then here you have cores. So these are what you refer to as cores, processor cores. Okay, so this course will define multi-threading. So talking about multi-threading, nothing but multitasking. I'll put it in a simple terminology, multitasking. So for example, in my machine, right now Teams is running, Microsoft browser is running, and GoToMeeting is running, and a lot of other tools you can see. PyCharm is running, Whiteboard is running, right? So let's say I have my processor is an octa-core processor. So meaning I can run 8 tasks in parallel. I can run 8 tasks in parallel. But there are almost close to 11 applications or 12 applications opened in my system. How is it possible? So basically, scheduling algorithm would come into picture, guys. There is another term which you need to understand, resources. There is another term which you need to understand, resources. When we talk about resources, right, it refers to memory, which is RAM, and then cores, CPU cores. Okay, these two together are what we call as resources. Okay, now for your task to run, we need resources. Okay, so why memory is needed? This is where your data is stored. This is where the data you're processing is stored, and this is where your program is getting executed. Executed in the sense your set of instructions is getting executed. Okay, so for example, you're watching a movie. So meaning you are actually running your VLC media player file or VLC media player code, okay, on an MP4 file or an .mkv file or whatever it is. Okay, so this is the data and you are processing this data using this set of instructions. Meaning whenever you are watching a movie, your file will be stored in RAM, and this set of instructions will be executed in one of these cores available. One of these cores available. Okay. Now talking about that is the reason we call both these things as resources. Both these things together, the RAM storage and then a processor core together as a, I mean, we call both of them together as resources. Okay. Now, uh, yeah, say for example, you press a play button, the code related to play button will be executed. You press a button, you press a pause button, the code related to pause button will be executed. Maybe you press a forward button, the code related to forward will be executed. That is how it runs. And now, you might ask me, boss, yours is octa-core, which means you can run 8 tasks, but how come are you running 12 tasks? Okay, so here the scheduling algorithms will come into picture, guys. Here the scheduling algorithm will come into picture. Okay, so the scheduling algorithm is nothing but it's an algorithm which would allocate resources to your tasks in a by following some one or the other algorithm. Okay, some example, the simplest algorithm being round robin fashion. So for example, you have 12 tasks running, and then it will give or allocate resources for task 1, for task 2, for task 3, for task 4, so on and so forth. So for example, I have 12 running, right? I have 8 octa core. So it will parallelly give some I mean, it will parallelly give resources to 8 tasks, and then it will rotate the remaining 4 tasks. That is what we call as round robin. Likewise, we have shortest job first, we have high priority job first, different algorithms. I'm not gonna deep dive into it, but yes, again, the juggling time between 2 tasks will be in microseconds or milliseconds that you can't even notice. Okay, now you might ask me, boss, why are you explaining all these things? There is a reason, guys. Whatever the Python program we write will be executed in this executor course, okay, or in this processor course, and whatever the variables you are creating or whatever the storage you are creating using this particular code will be stored in RAM. Okay, so for example, you have created a variable, or maybe you have created a list, or maybe you have created something, or maybe you are reading something from the file, or maybe you are reading something from the database. So all that would be pulled into the memory and then processed. Autoscaling is different, Ravi. Okay, say autoscaling is, let's say today you have quad core processor and then maybe 16 GB RAM. Let's say tomorrow if it demands 20 GB or 30 GB of RAM and then maybe hexa-core processor, the resources would be scaled up automatically, and then once you are done with the processing, they would shrink down. Okay, so that is what we refer to as autoscaling. So again, autoscaling is of two types. One is permanent autoscaling and second one is temporary autoscaling. Uh, Yeah, and the permanent auto scaling is like, you would scale it up, and then whatever the scaled up configuration you have will be persisted. And this comes for a different use case, and there are use cases where you need high amount of resources maybe once in a quarter, because let's say every quarter end, your load will be very high. Okay, or maybe that changes from organization to organization, but you would need only huge amount of resources during that particular time. So what we do is we auto scale it during that particular time and then shrink it down. So we call this second type as elastic nature. Okay, scaling up whenever needed and scaling down when not needed. Hope that makes sense. Okay, now talking about this thing, right? You know So basically, how much time your program is spending in this processor core is measured by time complexity. So time complexity is nothing but how much time your code is, it's basically a metric, guys. This time complexity is basically a metric. Time complexity is nothing but a metric which would measure how much time your code is spending in processor core. Okay, and then talking about space complexity, right? Again, it's a metric. Again, it's a metric which measures how much time your code is spending in, sorry, how much space your code is occupying in memory. Okay, so time complexity is a metric which would measure how much time your code is taking in processor, and space complexity is nothing but how much space your code is consuming. Is a metric to measure how much space your code is consuming. Okay, so there is a reason why the product companies would consider these two things as really, really important. Okay, because they always wanted to write the code or build a product in such a way that it will spend as minimal time as possible in your processor core, and it would occupy as minimal space as possible in memory. Okay, let's say, you know I have created a product. I have created a product which is not optimal at all, and the moment you are using my product, it is consuming all the RAM space and it is consuming all the processor cores, and it is your system is getting stuck. Would you really like to use my product, guys? Definitely not. You will tell that this product is useless and you will throw it out, no matter how, if I mean how important it is in terms of functionality. Okay, so that is the reason most of the product companies are really, really particular about programmers understanding space complexity and time complexity. Okay, are we good so far?
Yep.
Okay, now if you ask me how much do you know about space complexity and time complexity, I know to some extent, and rest is all French and Latin for me too, because I'm not aiming for Google or Microsoft. Okay, but it is always good to know and go in that direction. You know, at least I started my journey into that direction, but I just wanted to throw some light on that so that you will understand what it is, and you will try to adopt some practices right from the day one of your programming career. Okay, yeah, now going back to this, and next comes the classification of programming languages, guys. Okay, so one classification is low level versus high level. Low level versus high level programming language. And the second classification would be on procedural versus object oriented programming language. And the third one is compiled versus interpreted programming languages. Okay, so we will talk about these two today, and I'll be explaining this one tomorrow because I wanted to deep dive into this third point where I'll have to talk about compiler, executor, and other things. Okay, so but before that, let's talk about low level and high level programming languages. Any idea, guys, what exactly a low level programming language is and a high level programming language is?
Machine understandable language is low level, and human understandable language is high level, some sort of.
Yeah, that's correct. So basically, you know, talking about high level programming language, right? So high level programming language is something which is human understandable. Okay, meaning which is something you can understand. Okay, and low level programming language is something which is understandable by the machine. Okay, I hope most of you must be knowing your computer can understand only zeros and ones, right? It will not be able to understand what are the characters you are using or numbers you are using. Okay, so your computer is not capable enough to understand what those things are. Okay, so it can understand only low level things, right? So you might ask me then, boss, then whatever the code we are writing in Python will have all the characters, special characters, and then sorry, alphabet, special characters, and then numbers. So how can my computer understand it when it is capable enough to understand only zeros and ones? Okay, so we do have some would convert your high level programming language into low level programming language, and one such tool is compiler. So you talk about any programming, you have couple of components that would come into picture. One is compiler or compilation, first step, and second one is execution. Okay, so these are the two steps that would come into picture. We'll talk about that tomorrow. But yes, so talking about high level language, it is something which is understandable by you, and low level language is something which is understandable by the computer. So what are the programming languages you know? They are all high level programming languages, guys. C, C++, Java, Python. Okay, low level languages are assembly language or COBOL. They are the languages, low level language. They are the low level languages, machine level languages. Okay. And talking about procedural and oops. Okay, again this is a crucial classification. Okay, So talking about procedural, right? Procedural programming language will follow a top-down approach for executing your code. Okay. So for example, you start with step 1 and then step 2, step 3, step 4, step 5, so on and so forth. Okay. So it's a top-down approach. You start with some point and you will arrive at your solution. And talking about object-oriented programming structures, it's little different, guys. Okay, so uh, you have something called as classes and objects, and then you do the design first and then implement it. So a lot of different things that would come into picture. Okay, I know it might sound little French and Latin for you at this point in time, but you will be able to understand that when I start classes and objects concept or object-oriented programming structures module. So basically, I'll give you a simple example of class and an object, guys. Okay, which is the core component of object-oriented programming structures, or which is the heart of object-oriented programming structures. Let's say you have to open 5 notepads in your system, meaning you don't really need to install Notepad 5 times. You install Notepad once and then you create 5 instances of Notepad. Now, if you consider Notepad as a class, whatever the 5 notepads you are opening are nothing but the objects or the instances of that class. Okay, so this is the beauty of object-oriented programming structures, guys. Okay, which can share the common functionality and the common properties. Okay, so we're gonna deep dive, but yeah, talking about object oriented, we call this as a bottom up approach. The reason being you'll have to complete the design first and then create those classes and then use those classes for creating objects and calling the functions. Okay, so Python is an object oriented programming structure. Though it looks like a procedural way of doing things, but it is more of a object oriented programming structures, guys, because every variable you create here is an object. Okay, so let me take a pause here and we'll jump into the other topics tomorrow, where I'll be talking about the compilation, execution, and then the third difference, compiled versus interpreted, and then I'll be talking about Python features, after which I'll be jumping into Python variables and will show you the collab environment, which we will be using for our module 1 and 2. Okay, are we good? Cool. I hope you all enjoyed your first session. Okay, we'll see you tomorrow, guys. Till then, have a great day and good night for the folks joining from US. Thank you.